So if I see a 1 on the bottom here and the top here, this one must be in the middle. Oh, but then I look down and it can't be there, so therefore the 1 is there. Now, I kind of look all the 1s. Okay, so now looking at this. When I look in this box, the 1 can't be on the bottom. So the 1 is here, one of those 2 boxes. So if it's here and here, where does the 1 have to be in this box? If you have a 1 in this, on the left, on the right, then this one has to be in the center. Now I have the middle, the top, so here that must be on the bottom, but it can't be there. Now the 1 is here, here, so now I must put it into the middle column, and then I look here, so it has to go here, and then it has to go there. So now I'm done all the 1s. Okay, that's kind of my process. Some of you might have, you can figure it out in different ways. Like you might look, hey, 1, 2, 3, 5, 8. So I need a 4. Where could I put the 4? Etc. Okay, I'm not going to do the whole thing because it's a lot of time, but that's kind of the strategies if you want to practice one of those. Okay, number 2. I for sure put one of these on there. Okay, you ready? The first one is the 6 students use all 3 apps. So on this diagram, where would I put the 6 that use all 3 things? Right in the middle. The overlap of all 3. Okay, now you need an AND statement. So for instance, this one. 10 students use Snapchat and Facebook. So do you see where Snapchat and Facebook overlap each other? Is this. I need 10 students in this zone. But I already have 6. So now I'm going to put a 4 there. Do you see that? Don't put a 10 because now you're creating 16. Okay, I'm going to do this one third. 14 use Instagram and Snapchat. Instagram and Snap. So now I'm looking at this overlap. So there's 14, but I already have 6 in there. So now I'm going to put 8. Okay, let's do this one, 4th, the 3 students. Now this one is different. 3 students use only Instagram and Facebook. So what could I do on that one? Where it's just only just those 2? Then that would just be 3. So you don't have to do a minus on that one because this says they're only doing those 2. Okay, now I'm going to go up to the top. 30 students use Instagram. So can you get me 30 in the whole Instagram bubble? So I already have 8, 6, and 3. So that's already 17. And I need 30. So what does that mean? 13. Because now does that make 30 altogether? Okay, 25 use Snapchat. So inside the whole Snapchat bubble, I need 25. So 6 and 4 and 8, that's 18. So how many more do I need in that bubble? 7 more. And this is the last statement. So I need Snap or Facebook. Anywhere in the Snapchat or Facebook. So anywhere inside those, I need 30. So I already have what? 6, 4, 18, 25, 28. So now I need 2 more. Now all of that space would have 30 in it. How many students, this is the question, use only one type of technology? So on this map, who on this map is using just one device? This, and this. Because once you hit something overlapping, it means they're using 2 things. So 13 plus 7 plus 2 equals 22 people. Okay, there's one of these on the exam, so make sure you understand. Start with the overlapping, and then the singles, and then the ors. Okay, that's kind of the idea. The ands, the singles, and then the ors. Okay, I put some kind of a logic-y puzzle with just figuring out the numbers on there. So where would you start? I would start here. So that needs to add to 22. 16 plus, I need 6 more. I can only use these numbers once. Okay, now I can do this in the middle, because this all up and down has to be 18. So 6 and 8, that's 14. So now I need a 2. Okay. You ready? Oh, yeah. Thank you. Good math, hey? 4 would add to 18. Okay, so now I gotta readjust. Thank you. Sorry about that. Good thing you're on top of that. Okay. Now, here's probably where I would go next. So this has to add up to 7. So I already have 4. So these 2 boxes have to be a 1 and a 2, but I don't really know. So I could have the 1, 2, or I could do 2 and 1. I don't know. So I'm just going to write that in like that. Okay, now let's do this. If that is 13, the 2 empty boxes would have to make 6. So let's pretend this was a 1, then this would be a 5. If this was a 2, then this would have to be a 4. Oh, that doesn't work. The 4 doesn't work. I've already used it. So therefore, the 2 doesn't work. So therefore, it is a 1 and a 5. Okay, did you see kind of how I eliminated it? And then you would finish it up. So now that's a 2. And this should be a 3. Okay, on your exam, you need to understand the difference between inductive and deductive reasoning. Do you remember those words? So maybe this is the best way to kind of think about it. Inductive is when you use observations, and deductive reasoning is when you're using facts. So maybe it's a good idea if we start our cheat sheet, and maybe that would be something you would want to write on your cheat sheet. Okay, so which one is this? Students at Olivia's high school must have a B average in order to participate on sports. Olivia has a B, so she concludes that she would be able to participate in sports. So that would be deductive reasoning. Those are facts. You have to have that. Therefore, she concludes that. Holly notices that every Saturday her neighbor mows the lawn. Today is Saturday. Holly concludes her neighbor's going to mow the lawn. So that's going to be inductive reasoning. If Ellen stays up late, he will be tired. The next day, Ellen is tired. Therefore, Ellen stayed up late. What kind of reasoning? That's inductive. If a number is divisible by 4, then it's divisible by 2. 12 is divisible by 4. I'm going to now conclude 12 is divisible by 2. So I used which kind of reasoning? Deductive. Those are facts. Okay, coming up with conclusions. Two angles are complementary if their sum is 90 degrees. Angle 1 and 2 are complementary, thus what can we say? We can say their sum is 90 degrees. Okay, we are going to talk about these statements, if they're true or not true. Okay, so here I wrote, if this triangle is equal to this circle, and this square is equal to this circle, therefore this square would be equal to the triangle. Yes or no? Yes, that would be true. Because they are both the same amount, because they're both equal to the same circle. Chad is a human, Trump is a human, therefore Chad is Trump. that true or not true? No. Why isn't it? There are more humans than Chad. There's other humans. Trump could be another human. Okay, some people in this class are people who have attended W&M University. Some former presidents are people who have attended W&M. Therefore, some people in this room are former US presidents. Would that make sense or not? No. What's the logic reasoning why this isn't true? There's just other people to consider, right? Not every single person, so. Okay, many mammals are not human beings, so like animals. All students in this school are mammals. Therefore, some students are not human beings. Would that make sense or not? No. They're just using faulty logic there. They're not tying their ideas together. Okay, if a polygon is regular, then it means all sides are congruent. That's accurate. All sides of the polygon WXYZ are congruent, thus WXYZ is a regular polygon. Did they connect all the ideas together and conclude right? Yes. Okay, let's match each of these. So here's a person who did 6 times 2 plus 3 is the same as 6 times 2 plus 3, which is 15. So then I'm saying when you times an even number by an odd number, the product is odd. Is this true or not true? So what was their error that they made when they were trying to work that out? They made a math error, an error in a calculation. Do you see what they did wrong? That's their error. They would have needed to times the 6 by 3 as well. Or their order of operations was wrong. Okay, Jane likes blueberry muffins. Blueberry muffins have blueberries in them. Jane doesn't like muffins without blueberries. So that's not a good way. So what do you think this is? I would say she didn't really connect her ideas. She didn't really reason that out very well. She didn't connect the concepts together appropriately. Okay, all teachers drink coffee in the morning. Sarah's a teacher, so she drinks coffee every morning. What's wrong with this statement? This is a faulty assumption, right? Not all teachers do drink coffee. Jake does not go to school on a weekend. It is a weekend, therefore Jake is going to play soccer. So that one is faulty logic, not even connecting two ideas together. Okay? we're talking about not going to school, and now we're talking about soccer. There was no tying those ideas together. Okay? Unlike the Jane Blueberry one, she's trying to tie the ideas together, but she just didn't tie them together right. Okay, multiplication table, we have 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. Can you develop a conjecture about multiplying a number by 9 and its product? So these are the products. Is there any pattern that we can say? What is going on consistently? Is there anything that's the same with all of those in a pattern? They all add up to 9. The digits add to 9. So for instance, 7 plus 2 is 9. 6 plus 3 is 9. Is this true if we keep going? So 9 times 10 is 90. That would work. 9 times 11 is 99. That adds up to 18. So it wasn't true. It will eventually stop at 10. Counterexamples. When you square a number, you get something that's larger. So for instance, 5 squared is 25. That's larger. Okay? Is there something that shows me this is not always true? Because it isn't. Most of the time when you think about numbers, it will be, but what kind of number would it not be true for? Do you have something in mind? When you square something, it's going to not be bigger? 0 squared is 0. It didn't get any bigger. What else? There's something else. 1, right? Doesn't get any bigger. Or fractions. Because if you do a half squared, you end up with a quarter, which actually goes smaller, right? So that's a counterexample. Okay, all birds have wings, therefore all birds can fly. Is there anything you can think of that disproves that? Is there a counterexample? Flamingos. I think there's a few birds.
Penguins, octopus.
Chicken, penguin, ostrich, yep. A few examples. Okay, so that is logic.